Swayam Prabha. Digital India. Educated India.
Welcome to lecture 28 on time series modeling and forecasting. So far in previous lectures, we have discussed Decay and augmented Decay test for testing the presence of unit root in the time series model. We use Decay test when under the alternative hypothesis, under the hypothesis of stationarity. The process has a one term, means autoregressive term of order 1, and it may have constant term and linear trend also. And when the process has higher order autoregressive terms, or the process has a moving average and or autoregressive and moving average terms, then we go for augmented Decay test. We adjust the higher order autoregressive terms or the autoregressive moving average terms using the augmentation term in the model under null and alternative hypothesis, means the hypothesis of unit root and the hypothesis of stationarity. The problem with augmented Decay test is that this test requires the order of the augmentation term, and if the order of augmentation term under the alternate hypothesis is less than the actual process, means the actual process which has generated the data, then your residuals will be autocorrelated and it will affect the performance of the test. On the other hand, if you take augmentation term of very high order, higher order than the desirable or the process from which the data has been generated, then this test may have less power. So, it affects the power of the test. Phyllis Palantis provides an alternative to the augmented Decay test. It does not require the order of the augmentation term. So, in this lecture, I am going to discuss the Phyllis Palantis test for testing the unit root hypothesis. So, the ADF tests are usually less powerful and often in favor of acceptance of unit root hypothesis. This is a serious problem with augmented Decay test. It is often in favor of the acceptance of unit root hypothesis. Then an alternative is Phyllis Palantis unit root test. In fact, in Phyllis Palantis test, the test ignores any serial correlation in the test regression. So, while estimating the test regression, the Phyllis Palantis test does not consider any augmentation term, it ignores the serial correlation. And then for estimating the variance term, it uses non-parametric approach. In fact, it is the estimator of the variance term which adjusts for the serial correlation in the data. So, instead of the augmentation term, the serial correlation in the data has been adjusted through the estimator of the variance. So, we consider these 3 least squares regression equations. First equation is y t equal to phi star y t minus 1 plus u t star. So, this equation does not have any drift or trend. Then the second equation is y t equal to alpha head plus phi head y t minus 1 plus u t head. So, this equation has only drift term, this alpha head, and the third equation y t equal to alpha curl plus beta curl t minus n by 2 plus phi curl y t minus 1 plus u t curl. This equation has drift term alpha curl as well as the trend, this term. Actually, we have centered the trend term by subtracting the midpoint n by 2 from t. So, that is why we have taken here t minus n by 2. Then phi star is the least square estimator of phi in equation 1. So, what we do, we just run least square procedure for this equation, and then we obtain the least square estimator of phi here, and the corresponding least square residual is u t star. Similarly, for the second equation, we run regression between y t and y t minus 1 with a drift term, and alpha head and phi head are the least square estimators of alpha and phi respectively. Then u t head is the least square residual for equation 2. Similarly, for equation 3, we run regression between y t and y t minus 1 using this model. The model has drift term and linear trend, and then we get the least square estimators of alpha, beta and phi. We denote these least square estimators by alpha curl, beta curl and phi curl, and the corresponding least square residual term is u t curl. Now, suppose first we consider the equation 3, is the model which has both drift term as well as the linear trend. Then we write x equal to the first row of, in fact, this is x transpose here. So, the first row of x transpose has 1 at all places. The second row of x transpose has elements y naught, y 1, so on y n minus 1, and the third row, which is corresponding to the trend term, has elements 1 minus n by 2, 2 minus n by 2, so on n minus n by 2, and then we take transpose of this. So, you get X matrix. So, X is n by 3 matrix of explanatory variables for equation 3. Then corresponding T statistic for equation 1. Equation 1 means the model which does not have drift and linear trend. For that equation, the T statistic is T phi star equal to phi star minus phi summation y t minus 1 square to the power half upon S star, where S star denotes the standard error of equation 1. And under H naught, when you test the null hypothesis that phi is equal to 1, then this test statistic becomes phi star minus 1 summation y t minus 1 square to the power half upon s star. And then for alpha hat, the test statistic is the t ratio is alpha hat minus alpha into w upon summation y t minus 1 square to the power half divided by s hat. For phi, the t ratio is t phi hat equal to phi hat minus phi upon s hat w to the power half, and w is actually summation y t minus 1 minus y bar minus 1 whole square. Here y bar minus 1 is equal to 1 upon n summation y t minus 1. So, this is the mean of one period lagged observations. Similarly, for model 3, means these are the statistics for model 2. The first one is for model for equation 1, then for equation 3 the corresponding t ratios are t alpha curl equal to alpha curl minus alpha upon s curl square c 1 to the power half. For beta, it is t beta curl equal to beta curl minus beta upon s curl square c 2 to the power half, and for phi it is t phi curl equal to phi curl minus phi upon s curl square c 3 to the power half. Where s star, s hat and s curls are the standard errors for equation 1, equation 2 and equation 3, and C I denotes the ith diagonal element of x transpose x inverse. So, in fact, C 1 is the first diagonal element, C 2 is the second diagonal element, and C 3 is the third diagonal element of x transpose x inverse. Now, we consider some the following non-parametric weighted estimators for sigma square u, which are based on truncated sample autocovariances. In fact, for obtaining these estimators, we have used first m sample autocovariances of estimated residuals. So, this first estimator is for equation 1, that is for the model which does not have drift or trend. So, the estimator is sigma star n m square equal to 1 by n summation t equal to 1 to n u t star square. So, this part is actually gives you an estimator of sigma square u, a consistent estimator of sigma square u, which is based on the sum of square of residuals. We simply divide the sum of square of residuals by the number of observations. So, you get this part, and then you have the second part, which is the adjustment for the autocovariances or autocorrelations. So, that is the specialty of Phyllis Ballen test. Instead of adjusting the autocorrelations in the regression, it adjusts for the autocovariances or autocorrelations in estimating sigma square u. So, this second part is 2 by n summation I equal to 1 to m w I m summation t equal to I plus 1 to n u t star u t minus I star. Similarly, for the second equation, the estimator of sigma square u is sigma hat square n m equal to, again you have this first part which is based on sum of squares of estimated residuals, plus you have the second part 2 by n summation I equal to 1 to m w I m summation t equal to I plus 1 to n u hat t minus I. And then you for equation 3 you have the estimator sigma curl square n m for sigma square u. Now, m is the maximum order up to which auto covariances are included in the estimation of sigma square u. And then the weights W I m are taken as W I m is equal to 1 minus I upon m plus 1, I equal to 1 to so on m. So, this is how the Phyllis Ballen test adjust for the auto covariances or auto correlations. Instead of adjusting auto correlations in the estimating equation or in the regression equation, it adjusts for the auto correlations in the estimation of sigma square u. Now, first we consider equation 1, the model without drift and trend. Then the Phyllis Ballen test statistic for testing phi equal to 1 or gamma equal to 0 is z phi star equal to n phi star minus 1 minus lambda star upon m y y. And z t phi star is equal to s star upon sigma star n m t phi star minus lambda star dash sigma n m star divided by m y y to the power half. Where lambda star is given here, lambda star dash is equal to lambda star upon sigma star square n m, and m y y is equal to 1 upon n square summation y t square. So, apart from this t ratio, you have this term also here. Then we consider the equation with drift. Again, for this equation, the Phyllis Ballen test starts for testing single coefficient phi equal to 1, alpha equal to 0 is z phi hat is equal to n phi hat minus 1 lambda hat upon m bar y y, and z t phi hat is equal to s hat upon sigma hat n m t phi hat minus lambda hat dash sigma hat n m divided by m bar y y to the power half. And similarly, you define z t alpha hat also. Here lambda hat is equal to 1 upon 2 sigma hat square n m minus s hat square, and lambda hat dash is equal to lambda hat upon sigma hat square n m. M y y is again 1 upon n square summation y t square, and m bar y y is equal to 1 upon n square summation y t minus y bar square. So, then m y is equal to 1 n to the power minus 3 by 2 summation y t. So, this is how we define test statistic for the phi and alpha using Phyllis Ballen procedure. And suppose you want to test this hypothesis simultaneously, alpha gamma equal to 0 0. Means previous test statistic were for testing the significance of a single coefficient. This test statistic is for simultaneously testing the hypothesis that alpha is equal to 0, gamma is equal to 0. Then under the assumption of no trend in the data, we use this F statistic. F hat alpha p is equal to S upon STM F hat alpha minus lambda hat dash n gamma hat minus lambda hat upon 2 m bar yy. So, F hat alpha is the usual F statistic for testing alpha gamma equal to 0 0, this one. And then keeping in view the auto covariances, the F statistic has been adjusted using this term, and then this is the Phyllis pattern F statistic for testing the hypothesis alpha gamma equal to 0 0. Now, we come to the third model, the model with drift and trend. So, again we run least square for the third model, you get this equation. Then the Phyllis Palantis statistic for testing the single coefficients are Z phi curl is equal to n phi curl minus 1 minus lambda curl upon m, or if you write gamma equal to phi minus 1, then this is equal to n gamma curl minus lambda curl upon m. Similarly, you define Z t phi curl equal to S curl upon sigma curl n m t phi curl minus lambda curl dash sigma curl n m upon m to the power half. And then you have Z t alpha curl equal to this. So, basically you want to test the hypothesis alpha equal to 0, and for that purpose you use this statistic. Here actually this T alpha curl is the usual T statistic for testing the null hypothesis alpha equal to 0, the usual T ratio. And then we have adjusted this T ratio for the autocorrelations. Similarly, you define Z t beta curl also, because your model has this linear trend term. So, you may be interested in testing the hypothesis that beta is equal to 0. So, you can use this statistic for testing the hypothesis beta equal to 0. So, these statistics are for testing the significance of single coefficients, means this one is for gamma equal to 0 or phi equal to 1, this is for alpha equal to 0, and this one is for beta equal to 0. Again here lambda curl is defined here, half sigma curl n m square minus S curl square, lambda curl dash is equal to lambda curl upon sigma curl n m square, m t y is equal to n to the power 5 by minus 5 by 2 summation t y t, capital M is equal to 1 minus 1 upon n square m y y minus 12 m t y square plus 12 1 plus 1 upon n m t y m y minus 4 plus 6 n inverse plus 2 n to the power minus 2 m y square. Well, I have not given here the detailed derivation of all these statistics, but that part I am skipping. But for testing the significance of single coefficient, if you want to use the Phyllis Palantis, then you have to use these statistics. And suppose you are interested in testing the simultaneous hypothesis, say alpha beta gamma equal to alpha 0 0, means you are interested in testing the hypothesis that beta is equal to 0 and gamma is equal to 0. Then you use this F statistic, F curl n P1 equal to S curl upon sigma curl n m, F curl n1 minus lambda curl dash n gamma curl minus n to the power 6 lambda curl upon 24 determinant value of x transpose x. Here this F curl n1 is the usual F statistic for testing the hypothesis beta gamma equal to 0 0. And then you have adjusted this F statistic for the autocorrelations. And if you are interested in testing the hypothesis alpha beta gamma equal to 0 0 0, means you are in testing the significance of all the three coefficients, or you want to test the hypothesis that your model has no drift, no trend component, and it has a unit root, means it is an I1 process with no drift, no trend. Then again you can use this F statistic given by Phyllis and Ballen, F curl n P2 equal to S curl upon sigma curl n m, F curl n2, this is the usual F statistics. Then we have this term also which adjusts for the autocorrelations. So, these are the Phyllis Ballen test statistic for testing the significance of single alpha, beta or gamma equal to 0, or for testing simultaneously the hypothesis that beta gamma equal to 0 or alpha beta gamma is equal to 0, and so on. So, these test statistics correct the conventional regression statistics, means the conventional T statistic or conventional F statistic for the effects of serially correlated and heterogeneously distributed innovations. So, actually this Phyllis Ballen test procedure adjusts the test statistic for the serially correlated innovations or heterogeneous innovations. It adjusts the test statistic directly and it uses non-parametric estimators of sigma square u for all the three cases. But in running the regression for all the three cases, it does not include the augmentation term. So, at the stage of running regression, it does not bother about serially correlated innovations. Then each Z and F statistic involves an additive correction term capturing the effects of serial correlation. So, you must have observed that each of these Z and F statistic has an additive correction term, and that additive correction term actually takes care of the effects of serial correlation. And then the magnitude of correction term depends on the difference sigma star square n m minus S star square or sigma head square n m minus S head square or sigma curl square n m minus S curl square. Remember, these are the estimators of sigma square u which take care of the serial correlation. So, if this difference is large, the difference between the estimator which takes care of serial correlation and the estimator which does not take care of serial correlation, which is based on independent innovations. If this difference is large, then the adjustment factor is also large, and if this difference is small, so it shows that your innovations do not have serial correlation, or the innovations have very small serial correlation, then your adjustment factor is also very small. Again, I have not derived here the asymptotic distributions of all these statistics, but for the regression model 2, the statistics z phi hat, z t phi hat and z t alpha hat have the same limiting distributions as those of n phi hat minus 1, t phi hat and t alpha hat respectively. Similarly, for the regression model 3, the statistic z phi curl, z t phi curl and z t alpha curl and z t beta curl have the same limiting distributions as those of n phi curl minus 1, t phi curl, t alpha curl and t beta curl respectively. So, the details of the derivations I have not given here. Now, these are the steps for testing. Just like the augmented decay Fuller test, we perform the Phyllis Ballen test also in different steps. First, we test the hypothesis alpha beta gamma is equal to alpha 0 0, means the process has no trend and it is I1 process with drift, and in that case we consider model 3, means under H1 it has both, it has a linear trend, of course it has drift under both H0 and H1, and under H1 it is a stationary process. And then we use the F statistic F curl n P1, and then we also use test the unit root hypothesis gamma equal to 0 using T statistic Z T phi curl. In the next step, if the null hypothesis in step 1 cannot be rejected, it leads to the conclusion that there might be no deterministic trend. Acceptance of null hypothesis means there is no trend. Then we test a stronger null hypothesis H naught alpha beta gamma equal to 0 0 0, means there is no drift also, using F curl n P2. In step 3, under the assumption of no deterministic trend, means beta equal to 0, we test the hypothesis alpha gamma equal to 0 0, means the process is an I1 process with no drift, and for that purpose we use the F test based on the statistic F hat alpha p. In step 4, if the above hypothesis cannot be rejected, we test unit root hypothesis gamma equal to 0 for model without drift. So, if this hypothesis is accepted, then we take alpha equal to 0, we consider the model without drift, then we again test gamma equal to 0 or phi equal to 1, and for that purpose we use the T statistic Z T phi star. In next step 5, if the hypothesis of step 4 is rejected, then we test the hypothesis of random walk without drift by using Z T phi hat. So, we perform the test in different steps to reach the final conclusion whether your model has drift term or not, whether your model has trend or not, or whether your model is I1 process or not. Then in all the cases for t test, critical values are given by McKinnon. So, the tables for t critical values are available, and for f tests, critical values given by Decay and Fuller should be used. Then these are some remarks on the performance of ADF and Phyllis Palantis. In Phyllis Palantis, the results are less sensitive to small changes of the truncation parameter m. Means it does not affect your results very much if you misspecify the value of m. So, for the small change in this truncation parameter, the test is not affected very much. In ADF tests, if number of lag differences is too large, it adversely affects power of the test. Means if order of the augmentation term k is too large, it affects the power of the test. If it is too small, the test is no longer correctly applicable due to the autocorrelation of the estimated residuals. So, obviously, if you are taking k to be too small, number of terms in the augmentation term is too small, then your residuals have autocorrelation, and then your test is no longer correctly applicable. For the non-parametric Phyllis Palantis, the number of lags has no impact on the estimated parameters. So, because at the regression stage, we are not using any augmentation term. So, at the regression stage, we are not in fact taking care of such kind of autocorrelation in the innovation. And if the autocorrelation coefficients tend towards 0, they have a small impact on the estimated variance. Then in augmented decay Fuller test, there is one more problem. If you increase the value of k, it reduces the sample size, but the Phyllis Palantis does not have such kind of problem. So, this is one more advantage of Phyllis Palantis. So, normally to take care of the autocorrelation of the residuals, the performance of Phyllis Palantis is better than the augmented decay Fuller test. Now, we consider one more test, Kps test, which was given by Dennis Kwartzowski, PCB Phillips, Peter Smith and Y. Shin in 1992. Usually in all the unit 2 tests which we discussed earlier, your null hypothesis is the hypothesis that your process has unit root. So, your unit root hypothesis is the null hypothesis. Under null hypothesis, your process is non-stationary, it is I1 process. In Kps test, the null hypothesis H naught assumes that y's are stationary. Now, this is the basic difference between Kps test and other unit root tests. So, H naught is the hypothesis that y is stationary. So, the unit root is not present. So, this is contrary to usual unit root tests. So, whether you take augmented decay flow test or the Phyllis Ballen test, both the tests assume that under H naught the process has unit root. Then the Kps test starts with this model y t equal to alpha t beta plus beta t plus ut, and alpha t follows a random walk. Alpha t is equal to alpha t minus 1 plus epsilon t. Epsilon t is IID normally distributed. So, actually alpha t is the intercept term of this equation 1, and we assume that it follows a random walk. So, under H naught epsilon t is a constant, that is its variance is 0. Then we have to test if alpha t is a constant term or a random walk. Under H naught we assume that alpha t is a constant and alternate is alpha t is a random walk. Then the objective of the test is to detect this random walk. Then in step 1, y is regressed on a constant term and possibly also on a deterministic trend. You may include a deterministic trend also in this model. We have taken actually this trend here. Then in step 2, partial sums of the residuals UHT of these regressions are considered. So, we simply consider these partial sums, summation I equal to 1 to t u hat I j. J equal to 1 2, j equal to 1 indicates series is adjusted for mean, and j equal to 2 indicates series is adjusted for both mean and trend. So, we are considering both the cases when only constant term is present and when the process has both constant term as well as trend. So, this procedure is actually very simple. You have just to calculate these partial sums. Then for a stationary process, the sum of residuals is integrated of order 1. You know that UT is a white noise process. Then summation j equal to 1 to t. If you consider this process, this is a random walk. So, the sum of residuals is integrated of order 1, means this is I1 process. Then the Kps test statistic is eta j equal to 1 upon n square summation t equal to 1 to n s t j square upon s square u. J equal to means j equal to 1 to means for j equal to 1 eta 1 is the test statistic when you do not take into a trend term in your model, and j equal to 2 means you are taking the trend term in your model. Then the critical values for this test are given by Kps's. So, you can obtain the critical values, then you can compare the calculated test statistic with the critical values given by Kps's. and then you reach a decision. Now, we apply the Phyllis Ballen test and Kps test to real data set for demonstration purpose. We have taken this data set from South African Reserve Bank website, and the data set is on South African real gross domestic product, and in fact, we have taken data up to very recent, means up to year 2020. First, actually we have applied ADF test for testing the unit root hypothesis with drift and trend, with drift but no trend, and no drift, no trend. So, these are the results of ADF test when we have taken both constant and time trend. Then these are the test statistic. Corresponding critical values are also given at 1%, 5% and 10% level of significance. We conclude that we are able to reject null of unit root at 5%, and then we are able to reject null of no constant and no trend at 5%. We are also able to reject the null of no trend at 5%. Then we have applied ADF test when the trend term is removed. So, we are able to reject null of unit root at 5%, and then we are also able to reject null of no constant at 5%. All the means this is just for demonstration purpose, but once you have rejected the hypothesis of no trend here, then there is of course no point in going for this test ADF with constant only, because the previous result shows that trend is already there. Still, we have applied this test just for demonstration purpose. Then we have applied ADF with no deterministic. So, neither we are taking in constant term nor trend term. So, we are again able to reject the unit root hypothesis at 5%. Then we also applied Phyllis Ballen test, which gives this statistic value, and then we are able to reject the null of unit root. In fact, when we apply Phyllis Ballen test, we have taken truncation back parameter to be 4, m is equal to 4. Then we applied Kps test. So, Kps test for trend stationarity, the results are given here. So, in the final outcome is we are able to reject null of unit root using the Kps test also. So, results of all the 3 test procedures just they are the same, final results are the same. So, in this lecture we have discussed Phyllis Ballen test and then Kps test. Phyllis Ballen test takes care of the auto correlation in the innovations by adjusting it in the estimators of sigma square u, and then it adjusts the autocorrelations directly in the test statistic. It does not take into account these autocorrelations in the regression which you have estimated. So, it is free from the problem of selecting the order of augmentation term. And another advantage is that the truncation parameter or a small change in truncation parameter, you can say, does not have much impact on the performance of the test. So, whereas the augmentation, the ADF test is quite sensitive to changes in the order of the augmentation term k. So, this is the advantage of Phyllis test. Then we have also considered Kps test. The test statistic is quite simple to calculate, and another special feature of Kps test is that it assumes the hypothesis of stationarity under H naught. So, under H naught it assumes that the process is stationary. So, here I am going to stop. Thank you.
Hello, I am A.K. Sharma and I teach sociology in IIT Kanpur. You may ask, how do sociologists view religion? Religion is becoming an important issue for our society. Now, sociologists, this is true that sociologists explain one thing in terms of other things of society. So, religion, if you ask sociologists to explain religion, they will explain religion in terms of other things of society like education, economic development. In sociology of religion, there are two major traditions actually. In one tradition, to use language of methodology, in one tradition religion is a dependent variable. In another tradition, religion is an independent variable. What I mean is that in the view of Karl Marx, who said that religion is the opium of the working class, religion is closely associated with contradictions or relations of class in society. Marx believed that as time passes, societies evolve, and this evolution of society is dialectical, like from a classless society to a class society, class formation, and eventually again a classless society will emerge. Karl Marx believed that laws of human behavior or laws of society are specific to stage of development of society and are closely associated with mode of production or tools and techniques of production and ownership of tools and techniques of production. To Karl Marx, who think that a modern society is a capitalist society, religion is the dependent variable which needs to be explained in terms of class relations. And when he says that religion is the opium of the working class, it means that religion is used by the powerful class, the class which owns the means of production, to legitimize their class position or to confuse the workers. Let the workers think that if they are poor, if they are exploited, and if they suffer from various kinds of problems, it is because of their fate or their deeds in the previous births, and not develop the revolutionary consciousness to analyze the real causes of their poverty or exploitation or ill health. This is one view, and religion is the dependent variable. which also means that tomorrow in socialist society or in communist society, if it ever emerges and society becomes classless once again, religion may not exist. Now, according to another view, Max Weber, religion is actually the independent variable that explains emergence of something else, and that something else is the emergence of capitalism. Max Weber said that unlike in the Hindu countries or the Muslim countries or Christian countries where influence of Catholic Christianity was rampant, capitalism as we understand by capitalist institutions, capitalism could not have developed. It does not mean that people, Hindus or Muslims or Catholic Christians, they were not acquisitive in nature, but there was a difference between them and those influenced by Protestant ethics in certain countries of Western Europe, and the difference was that these people did not use what they earned from their enterprises for comforts or for saving or for security or for status or prestige, but whatever they earned from their enterprise, they further invested this in the enterprise itself, and they lived simple life. By living simple life and spending the earnings back in the enterprise leads to emergence of capitalism in Western Europe. Here you see that religion is the cause. So, at some point of time, some philosopher, his name was Calvin, who gave a new turn to Christianity and propounded the philosophy of a new philosophy of Protestantism, also called Puritanism, the theory of predestination, which created anxiety in people's mind to know whether they are elect or not, whether after their death they will go to hell or heaven. So, this reinvesting in enterprise and not using the profits for their own gains or for their own comforts, this produce capitalist society or industrialization, in simple language industrialization, or this produce economic development first in the countries of Northwest Europe. And another issue which sociology tackles with regard to religion is whether we are secularizing. Now, it has been found that in the Western countries with urbanization, economic development, industrialization, education, democracy, there is a fall in religiosity. But in our country, secularization is defined in a different way, because we are a plural society, and for thousands of years all religions have been juxtaposed in our country. So, we define secularization as a process in which state maintains equal distance from all the religions, but does not become irreligious state. So, but this kind of definition or this approach of state obviously is going to raise new issues, new social problems and religious issues, other issues, but this is what it is. So, sociologists of religion will also study this process of tensions in the process of secularization in a plural country like India. Thank you.